Namaste dear children, I am Rekha. Welcome to my channel Rekha's Knowledge Hub. Today we will see NCERT Classic Science Chapter 7 Temperature and its Measurement Part 2. Children, we have already studied about clinical thermometers. Next we will see laboratory thermometer. There are many types of laboratory thermometers, but the one that might be available in your school laboratory may look like the one shown in figure 7.3a. So there are different types of laboratory thermometers. In your school, you can see laboratory thermometer like this in figure 7.3a. It consists of a long, narrow, uniform glass tube which is sealed. At one end of the tube is a bulb which contains a liquid. Outside the bulb in the tube, a narrow column of liquid can be seen. There is a Celsius scale marked along the tube. The liquid column rises or falls with change in temperature. The mark of the Celsius scale with which the top level of the liquid column coincides is the temperature reading. So, this thermometer, it consists of a long, narrow, uniform glass tube, and this tube is sealed. At one end of the tube is a bulb. This bulb contains a liquid. This bulb is the bottom part of the thermometer. Bottom bulb-shaped part of the thermometer. It contains a liquid, usually mercury or alcohol, which expands or contracts with the temperature changes. Then outside the bulb, in the tube, a narrow column of liquid can be seen. You can see a narrow column of liquid inside the tube, outside the bulb. Then there is a Celsius scale marked along the tube. The liquid column will rise or fall with a change in temperature. The mark of the Celsius scale with which the top level of the liquid column coincides is the temperature reading. So, to read the temperature, position your eye at the same level as the liquid in the thermometer. Look for the point where the liquid meets the Celsius scale. The number at that point is the temperature reading. The liquid used in the laboratory thermometer is generally alcohol colored red to make it easily seen or mercury. So, the liquid used in laboratory thermometer is generally alcohol. It is colored red. For what purpose? To make it easily seen, or the liquid may be mercury also. Let us observe. Let us try to find the temperature range of a given laboratory thermometer. We have to find the temperature range of a given laboratory thermometer. Take a laboratory thermometer and observe it carefully. Precautions to be taken while using a laboratory thermometer. We have to take some precautions while using laboratory thermometer. Handle with care. If it hits against some hard object, it can break. Do not hold it by the bulb. These things you have to take care of. So, take a laboratory thermometer and observe it carefully. Note down the following. What is the lowest temperature it can measure? It is minus 10 degrees Celsius. What is the highest temperature it can measure? It is 110 degrees Celsius. So, the range of this thermometer is minus 10 degrees Celsius to 110 degrees Celsius. Now, look at the thermometer shown in figure 7.3a carefully. Can you tell its range? Its range is from minus 10 degrees Celsius to 110 degrees Celsius. Let us observe and calculate. Let us now try to find the smallest value that a given laboratory thermometer can read. We have to find the smallest value that a laboratory thermometer can read. Again, take the same laboratory thermometer which you used in activity 7.3 and observe it carefully. We have to take the same laboratory thermometer. See this. Note down the following. How much is the temperature difference indicated between two bigger marks? Can you see these two bigger marks? How much is the temperature difference indicated between the two bigger marks? It is 10 degree Celsius. How many divisions shown by smaller marks are there between these two bigger marks? Between these two bigger marks, how many smaller divisions are there? You have to count from here. 1, 2, 3, 4, 5. Then 6, 7, 8, 9 and 10. Okay, so total 10 divisions are there. How much temperature does one small division indicate? There are 10 divisions. And between these two larger marks, it is 10 degrees Celsius. So, one small division indicate 1 degree Celsius. So, the smallest value that the thermometer can read is 1 degree Celsius. We will see in details. Figure 7.3b shows a close-up part of the thermometer shown in figure 7.3a. Can you now find the smallest value that this thermometer can read? For the thermometer shown in figure 7.3b, the temperature difference indicated between 0 degrees Celsius and 10 degrees Celsius or between 10 degrees Celsius and 20 degrees Celsius is how much? It is 10 degrees Celsius. So, the temperature difference between 0 degrees Celsius and 10 degrees Celsius or between 10 degrees Celsius and 20 degrees Celsius is how much? It is 10 degrees Celsius. And the number of divisions between these marks are 10 divisions. There are 10 divisions between these two bigger marks. So, one small division can read 10 by 10, that is 1 degree Celsius. That is, the smallest value that this thermometer can read is 1 degree Celsius. There are 10 divisions between two bigger markings. Okay, so each small division indicates 1 degree Celsius. Your school laboratory may have thermometers for which the range and the value of the smallest division may be different. In your school, your laboratory thermometers might have different range or the value of the smallest division may be different. It is therefore always necessary to look carefully at the thermometer you are about to use. You have learned how to find the temperature range of a given laboratory thermometer. You have also learned how to find the smallest value that a given laboratory thermometer can read. So, you have to find the number of smaller divisions between two bigger readings. Okay. Also, you have to find the temperature difference indicated between two bigger readings. Then you can find the smallest value that the given laboratory thermometer can read. We will now learn how to measure temperature using a laboratory thermometer. But let us first learn how to use a laboratory thermometer correctly. We have to learn how to use a laboratory thermometer correctly. Correct way of measuring temperature using a laboratory thermometer. See this picture. See, there is a beaker. It contains warm water. Then there is a laboratory thermometer. Then this is the close-up of a part of laboratory thermometer. Okay. So when the thermometer is immersed in water, its bulb should not touch the bottom or the sides of the beaker. See this figure? When you immerse the thermometer in water, its bulb should not touch the bottom or the sides of the beaker. Okay. The thermometer should be held vertically. How to keep the thermometer? It should be held vertically and should not be tilted. You should not tilt your thermometer. The temperature must be read while the thermometer is immersed in water. You have to read the temperature when the thermometer is immersed in water. While reading the thermometer, the eye should be directly in the line with the level of the liquid column to be read. So when the thermometer is immersed in water, keep the bulb away from the sides and bottom of the container. Okay. Also, how to read the temperature? You have to position your eye at the same level as the liquid in the thermometer. The thermometer should be held vertically and it should not be tilted. Also, the temperature must be read while the thermometer is immersed in water. Let us measure. This is an activity. Take some warm water in a beaker. Dip the thermometer in water so that the bulb is immersed in water. Observe the rise of liquid column in the thermometer. So you take some water in a beaker and dip the thermometer in water so that the bulb is immersed in water. Then the bulb should not touch the sides or bottom of the beaker. Observe the rise of liquid column in the thermometer. Wait till the column stops rising and note the temperature. Do not wait too long. Why? Because the water itself will start to cool. So do not wait too long. What is the temperature of water measured by you? Compare it with the readings of your friends. Do you notice that as soon as you take the thermometer out of the water, the level of the liquid column begins to fall. This means that the temperature must be read while the thermometer is immersed in water. You have to read the thermometer while the thermometer is immersed in water. When you take the thermometer out of the water, then what will happen? The level of the liquid column begins to fall. Following two experimental setups are to be arranged by your teacher. One by one, as per your turn, go closer to the setups and observe the readings of both the thermometers. What are the temperatures of ice and boiling water? See, there are two experimental setups here. See these two pictures. In the first figure, there is a laboratory thermometer and there are some crushed ice. Then, the second figure, there is a laboratory thermometer. Then, in the beaker, boiling water is there. Then, also a burner is there. You can see the burner here. Read the temperatures of ice and boiling water again after some time. First, you read the temperatures of ice and boiling water. After some time, again you read the temperatures of ice and boiling water. Are the temperatures same or have changed? You may have noticed that the temperature of water remains constant while it is boiling. Also, the temperature of ice remains constant while it is melting. So, the temperature of water remains constant while it is boiling and the temperature of ice remains constant while it is melting. Let us compare. Fiban's science teacher arranged the experimental setup for measuring temperature of boiling water. The temperature reading of the boiling water taken by Fiban and her classmates in Shillong are given in table 7.2. See this table, temperature of boiling water. This is an experiment done by Fiban's science teacher. See, Fiban, the temperature of boiling water is 97.8 degrees Celsius. For Shemfang, it is 98.0 degrees Celsius. 1 star, it is 97.9 degrees Celsius. Chloe, it is 98.0 degrees Celsius. Bandarisha it is 98.1 degrees Celsius. Compare the temperatures of boiling water recorded by different students. Why are there differences in their readings? Discuss the possible reasons among yourselves. Maybe the correct way of reading temperature was not followed by all the students. Several factors can contribute to variations in temperature readings of boiling water recorded by different students. Maybe a human error. Reading the thermometer incorrectly can lead to errors in the recorded temperature. Also, maybe some environmental factors, for example, room temperature, air pressure, and humidity. They can influence the boiling point of water. So, small variations in these factors can lead to slightly different temperature readings. Next one, air temperature. You might have seen the thermometers such as the ones shown in figure 7.5. See this figure, this is a room thermometer. Hung on walls of your school laboratory, doctor's clinic and hospitals. These give an approximate idea of the room temperature. Have you seen weather reports in newspapers, TV news or internet? These reports also mention the maximum and minimum air temperature of the day. So, air temperature is a measure of how hot or cold the air is. Then factors affecting air temperature are solar radiation, then altitude, proximity to water bodies, wind patterns, human activities, etc. The amount of sunlight a location receives influences its temperature. Then higher altitudes generally have lower temperatures. Then water bodies, they can moderate temperature extremes. Wind can influence temperature by bringing in air from different regions. Then human activities like burning fossil fuels, they can contribute to global warming and increase air temperatures. Then there is an activity, read or listen to the weather reports for a place for 10 successive days. Record the maximum and minimum air temperature for each day. Analyze the data in table 7.3. Okay, so you have to listen to the weather reports for a place for 10 successive days. And you have to record the maximum and minimum air temperature for each day. These things you can do. Does the maximum and minimum temperature stay at the same level during these days? Because weather depends on several factors. I have already said these temperatures usually vary every day. Generally, as we approach the summer season, the temperature rises, and during the winter season, it falls. So, it depends on several factors. There are many techniques for measuring air temperature. Air temperature is an important weather parameter and is monitored at weather stations all over the world. The data gathered on air temperature along with various other parameters are used for making weather forecast. So, air temperature is typically measured using a thermometer. Air temperature, it plays a very important role in various aspects of our lives, including weather patterns. It influences weather conditions like rain, snow, and wind. Then it is very important in the field of agriculture, then climate change, etc. Know a scientist, Anna Mani, 1918 to 2001, was an Indian scientist, also known as the Weather Woman of India. This is very important. Who is known as the Weather Woman of India? Anna Mani. She invented and built a large number of weather measurement instruments. She invented a large number of weather measurement instruments. This reduced the reliance of India on other nations for such instruments. She also explored the possibilities of using wind and solar energy in India. She also explored the possibilities of using wind and solar energy. Her work helped India to become one of the global leaders in renewable energy. What do you mean by renewable energy? Renewable energy is energy derived from natural sources that are replenished at a higher rate than they are consumed. Unlike fossil fuels, which are finite resources, renewable energy sources are virtually inexhaustible. So, common types of renewable energy include solar energy, wind energy, hydropower, geothermal energy, then biomass energy, ocean energy, etc. Summary. The temperature of a body tells us how hot or cold it is. The three most used scales of temperature are the Celsius scale, then the Fahrenheit scale and the Kelvin scale. The units of temperature in these scales are degree Celsius, denoted by degree capital C. Degree Fahrenheit, denoted by degree capital F. And next is Kelvin, denoted by capital K. The SI unit for temperature is Kelvin. A clinical thermometer is used for measuring body temperature. Then, normal temperature of a healthy human adult is taken to be 37.0 degrees Celsius or 98.6 degree Fahrenheit. Laboratory thermometers typically have a temperature range from minus 10 degrees Celsius to 110 degrees Celsius. Let us enhance our learning. The normal temperature of a healthy human being is close to 37.0 degrees Celsius. Then 37 degrees Celsius is the same temperature as 98.6 degree Fahrenheit. Then fill in the blanks. The hotness or coldness of a system is determined by its temperature. The temperature of ice cold water cannot be measured by a clinical thermometer. The unit of temperature is degree Celsius. The range of a laboratory thermometer is usually minus 10 degrees Celsius to 110 degrees Celsius. Minus 10 degrees Celsius to 110 degrees Celsius. 4 students used a laboratory thermometer to measure the temperature of water as shown in figure. See this figure. 4 students, they used a laboratory thermometer to measure the temperature of water. Who do you think followed the correct way of measuring temperature? Student 2. See, the bulb of the thermometer should not touch the bottom part or the sides of the beaker. Also, you must hold the thermometer vertically without tilting the thermometer. Color to show the red column on the drawings of thermometers as per the temperatures written below. See, in the first thermometer it is 14 degree Celsius. So, this is the 14 degrees Celsius. 14 degrees Celsius will come here. So, you can color like this. See the next thermometer. Here it is 17 degrees Celsius. So, you can mark 17 degrees Celsius here. Okay. So, you can color like this. Next thermometer is 7.5 degrees Celsius. So, it will come here. See here, each smaller division is 0.5 degrees Celsius. So, you can color like this. Observe the part of thermometer shown in figure 7.8 and answer the following questions. What type of thermometer is it? This is a laboratory thermometer. What is the reading of the thermometer? The reading of the thermometer is 26 degree Celsius. So between 20 and 30 there are 10 small divisions. So each division is 1 degree Celsius. Then what is the smallest value that this thermometer can measure? It is 1 degree Celsius. A laboratory thermometer is not used to measure our body temperature. Give a reason. We cannot use a laboratory thermometer for measuring body temperature. Why? Because a lab thermometer is very long and is difficult to handle. It has a wide range of measurement, degrees from negative to positive. This means they are less sensitive to small changes in temperature, making them less accurate for measuring the precise temperature of the human body. So it is very difficult to measure the precise temperature of human body using a laboratory thermometer. It has a wide range of measurement. Also, it is very long, so it is very difficult to handle. Vaishnavi has not gone to school as she is ill. Her mother has kept a record of her body temperature for 3 days as shown in table. See this table. What was Vaishnavi's highest recorded temperature? It is 40.0 degrees Celsius. Then, on which day and at what time was Vaishnavi's highest temperature recorded? Day 1 at 7 p.m. On which day did Vaishnavi's temperature return to normal? On day 3, temperature returned to normal, that is 37 degrees Celsius. If you have to measure the temperature 22.5 degrees Celsius, which of the following 3 thermometers will you use? See, you have given 3 thermometers. Which one will you use to read 22.5 degrees Celsius? So, we can use thermometer B. Why? Thermometer B has smaller divisions, so it will give a more precise measurement of 22.5 degrees Celsius. Here each small division is 0.5 degree. The temperature shown by the thermometer in figure 7.10 is, what's the temperature here? It is 27.5 degree. Here each small division is 0.5 degree. So, this measurement is 27.5 degree. A laboratory thermometer has 50 divisions between 0 degree Celsius and 100 degree Celsius. What does each division of this thermometer measure? Number of divisions is 50. Range is 0 degree Celsius to 100 degree Celsius. Therefore, each division is equal to 100 degree Celsius minus 0 degree Celsius divided by number of divisions, that is 50. So, you will get 2 degree Celsius. So, each division is 2 degree Celsius. Draw the scale of a thermometer in which the smallest division reads 0.5 degrees Celsius. You may draw only the portion between 10 degrees Celsius and 20 degrees Celsius. See this. Here you have to draw only the portion between 10 degrees Celsius and 20 degrees Celsius. Here the smallest division reads 0.5 degrees Celsius. See, you have to draw like this. Someone tells you that she has a fever of 101 degree. Does she mean it on the Celsius scale or Fahrenheit scale? She means it on the Fahrenheit scale. A normal body temperature on the Fahrenheit scale is around 98.6 degrees. Therefore, a reading of 101 degrees Fahrenheit indicates a fever. The temperature at the core of the sun reaches as high as 15 million degrees Celsius. Are there objects in the sky that have even higher temperatures? There is no limit on the highest temperature that can exist. There is no limit. However, as per scientific understanding, there is a limit to the lowest temperature that can be achieved. For the lowest temperature, there is a limit. It is close to minus 273.15 degrees Celsius. that is 0 Kelvin, and is called absolute zero. So this temperature, this lowest temperature is close to minus 273.15 degrees Celsius or 0 Kelvin. It is called absolute zero. Children, thanks for watching. If you like this video, please like, share and subscribe. We will see you in the next video. The playlist for various subjects are given in the description box. Please go through it. Thank you.